Well, hi, good morning. It's January 20th, and I'm ready for another run at this radio. What I've started working on here is the replacement of the electrolytic capacitors in the power supply filter system. That's this one and these four. So to replace this one, I've made up a little collection of similar sized, same size capacitors here. There's 3 capacitors in here, 3 on here. My plan is to mount this down here on one of these screws or nuts and just bring the wires from here over to here. This one's done. These ones I haven't studied quite enough, but it looks pretty simple to do it one by one, and these are the replacement capacitors for that. The reason I'm doing this is it's not so much that I'm afraid these are going to fail. I'm not, but maybe they are. Okay, so what I have in my head doesn't really matter. There is the potential for a failure of one of these, a short circuit or something like that, maybe. And if that were to happen, I think it puts some parts at risk here that would basically write the radio off. If you burn out a big coil or something like that, you have to get another one of these radios to fix it. So, so that's why I'm doing it. There's a slight hum in the radio we can hear in the speaker. That's a hum I don't normally hear from this radio. Could be it's just being introduced by the way I'm running the sound in my shop, or maybe it is coming out of the radio and I've just never really noticed it before for some reason. So maybe we'll eliminate a bit of hum. One thing's for sure, if I do this and the hum remains in the radio, then we know there's something more wrong in the radio. Not likely. Not likely. Most likely just coming from my schlocky audio connections here. So I'm just going to carry on without the video running. I know I say that quite a bit and then you watch me do something, but I don't think this time. So I'll get all this done and then we'll test the radio. Okay, so that's the big main filter capacitor now. I've replaced it with these 3 on the terminal strip here. Run some new wires back to the place where they were on here. That's good. So what's next are these guys, and you know there's one more up here too. I should probably think about relieving this one also. These are all 10s, I think. 10 at 300. I think, yeah, they're all 10 at 300. And this is what a 10 at 300 looks like today. This is actually 10 at 350. Smaller, right? Okay, so I got to figure out how to put them in here and do a nice job of it in that. You know, I think before I just put alternates in, I can test one of these and see what I can see with it. I think I can just lift this one lead off here. If I'm going to replace it, this lead has to come off anyway. There we go. So now the capacitor is out of the circuit, I can test it in its place there. Let me get my little... Okay, now don't be scared, big radio, because a piece of technology is coming up you couldn't even imagine existed back when you were built. Couldn't have even imagined this. Okay, let's see what it says. Oh, thinks it's a resistor. That's bad. That's really bad. Why? Oh, you know why? Because I hooked it up to the wire, dummy. Hook it up to the capacitor this time. Let's try it again. Yeah. Pretty sure it's not a resistor. Okay, let's try that again. Oh, it thinks it's a capacitor this time. 16 microfarads. It's supposed to be 10 and it's reading 16. So that's a sign of a leak. V loss 2.6%. And the effective series resistance 1 ohm. Now, some of these readings you never have paid attention to back in the day. What we can't tell from this really is its leakiness. So we're going to try another tester on here. It's a large capacitor, so I can actually run pretty large leads all the way from my capacitor checker here. I have another capacitor checker. Let's try this other one. I'll get things set up for it here, and we'll run it. We'll run a test. Okay, so other than doing some experiments with this capacitor checker, I don't have an awful lot of experience with it. It won't come on until I turn on the switch here. Okay, give it a moment for the eye to come on. There's the paper, mica, mini lytic, whatever that is, electrolytics. That's where we want this set. There you can see the eyes coming on. We want to check. So in this position, it's in discharge position. So there's a short on here right now. I don't have it connected. Here, capacitor range. C times 1. Where do I get up into electrolytic? So you have to have a scale specifically for electrolytic. One scale. One scale for the whole, wait a minute, times 1. So we're going to go times 1 on the capacitance scale. There's 50, 40, 30, 20, 10. 10 is here. 10 is here. That's where we think the eye should open on this capacitor. Okay, I think I know what I'm doing. I think I know what I'm doing here. Voltage, that's for the leakage test. Okay, so we'll hook it up. We'll do the leakage test first. Now, I need to watch the eye here as I raise the voltage. Let me just see if I can get a little of the light off. A little less light in here. Make the eye a little more dramatic. It's very difficult to get these things on camera. Just there. Well, even there. How about there? There. No. Fool my camera around here. Well, you know, I'm not going to be able to get it to show very well. Hey, let's call it that. So you see the opening in the bottom of the eye anyway. So I'm going to raise the voltage here and we'll watch the eye. So nothing's happening whatsoever. We're on leakage. This power factor switch shouldn't matter. This switch shouldn't matter. All that matters is this. And what we're finding is no leakage so far. How many volts can these guys take? So these are in the 50 volt circuit. I don't think they can take too much. We're at 50, go 100. There's absolutely no movement here, so something's not right. Something is not right. Something is not right. There's just no way that should show up that way. Here, should be some leakage on that. Nothing happened. Okay, am I going to try to sort this out now? I don't think so. Let's just flip it down to paper here. Down to the paper setting. That should be closing. Bad leads. Yeah, I got bad leads. Bad leads? Maybe bad leads. Let's try another. There we go. Bad leads. How do you like that, eh? Bad leads. They just hung them right back up on the wall there. So this should be back on electrolytic. Put this back on discharge. We'll hook them up. Hook them up. Very good. Leakage. electrolytic 150 volts. It didn't show a thing. Now, just to verify, I'm going to flip it to paper. It's much more sensitive on paper. Is this voltage thing doing nothing? It's got to be doing something. Okay, so I'm not sure what's going on here at all. This is just not behaving the way I expected it to. So, so you know what we're going to do? We're going to revert to the tester that I have used so much. This one here. I don't know what happened here. I'm going to have to play around with this other one for a while. Try to sort it out. This guy I've used a lot. They're both Heath kits, but their calibration is different. Okay, so the first test is going to be a leakage test at 50 volts. Set for electrolytic. Can you see the eye is open at the bottom? This control doesn't matter, but it should be off to the left. So 50 volts, what happens? It just popped right open, like it's not even connected. The eye should close, and then as the thing charges up, it should open. What are we finding out? These capacitors are no good at all. So I'm going to put a dead short on here. Okay, no. So the leads appear to be good. I'm finding something I don't believe, and that is bad. These big capacitors are bad. Really? Is it really 50 volts? I don't like how it's popping open like that. 150 volts. It's, from my experience, when you test a capacitor that should show a charge time, especially a big one like 10 microfarads, the eye should close and then it will open. In my experience, when it pops open like that, it's telling you there's virtually nothing connected to it. It thinks there's nothing over there. So, and that, I believe, leads back, comes from a disconnected lead inside the capacitor. But look at the capacitors I'm testing here. It's these big metal ones here. Great big honking connections. This is all military grade stuff. Meant to be tossed around, bashed around, but not meant to be working in the year 2020. I don't think that's the case. Let's measure the its capacitance. See what that shows up as. So 10 would show up on this scale. And watch the eye for an opening. Did not open. It opens right down here at the very end of the run, and you can't rely on that at all. Let's go smaller. Now it's open all the time. What's happening? So every test I've done is suggesting this capacitor is kind of shot. Even the original one with the electronic meter suggested its capacitance was above its original amount. Now, electrolytic capacitors, back in the day when they were being manufactured, they could not be manufactured with precision. This may not be true of these ones, but typically they would come out of the factory and they'd say this is a 20 microfarad electrolytic capacitor, and it was actually a 50. So is it possible that it's labeled 10, but here in the year 2020 it measures 15 or whatever it was? All indications are these are bad so far. What more could I do? A really crude test, I guess. I'd stick an ohmmeter right on it. No, that's not going to work because it appears to me it has an open circuit inside it. You know, I think if it had an open circuit lead, like this lead doesn't actually make it in there anywhere, somewhere underneath here it's broken, then that first test would not have shown any capacitance. I don't know what to make of these guys. I know this though. I can put these ones in and not worry about this at all anymore after that. Thumbs up on that. Just got to check the voltage. I think these are actually quite low voltage. Maybe I'm wasting some higher voltage capacitors here, so I'm just going to recheck on all that, and then I'll install these little capacitors down here somehow, and we'll be good to go again. Okay, I've got all those capacitors installed now, and I think what we should do is take a pretty close look at all the connections I made. I had a lot of trouble with some of these. Old wires did not want to take the solder very much, so we'll take a look at the first the 3 capacitors here. Real bundle up of wire here. Use a little more solder on that connection, I think, but it's solid. Yeah, it looks good. A lot of trouble with this connection, but it's solid. Looks ugly, but it's solid. Okay, all the wires are off the end here. There's nothing, I didn't leave anything behind. Nothing sneaking around underneath there. Oh, there is something sneaking around underneath there. Oh my gosh, there's a wire under there. Is there? Is that a wire? Huh? Uh-oh. If I left... No, there's nothing there. I'm daydreaming here. No, there's nothing there. For sure. Okay. Spooked out. Big time there. Okay, look at the other capacitors I've done. That's on these big guys here. So what I've done is I've just laid the new capacitor between the old terminals, and then I soldered one side to one terminal, leaving it in place, but I disconnect the other terminal so the old capacitor's not doing anything, and stick this terminal to it, so because this one's got a wire on it. It's good. Let's see the next one, because it's kind of just jammed in there, so it actually is a nice job actually to do. I had a heck of a time soldering this. Believe it or not, I think that's okay, as ugly as it is. And a little bit of concern about making a short circuit here. It looks fine. Come down here. No, that's good actually. Can have a heck of a time soldering that resistor. Now that doesn't look good. It's really hard to tell. Let me poke at it here. The thing is, it looks great with my eyeballs, you know, with my vision. My vision's not, well, I'm wearing glasses, but from a distance you'd never know there's a problem there. Looks like it could use a little more solder. What if I squeeze it down here? I wonder if I can do that. Not really. There. Oh! Did I just break something? No. Okay, so I'll resolder that one. And over here. Okay, these just look terrible, but they're actually okay. Okay. That's 1, 2, 3, and 4. I still have this one up here I have to think about. I should do it. If I'm going to do them, I should do them all. Yeah. Okay. Yeah, better do that last one. Solder that one connection there, and then do the last capacitor. You know, at first glance, it looks pretty scary to try to change something like this. But really, all this one amounts to is cutting the wire from here, goes right to this terminal. Just cut it, solder the new guy to the terminal, and bring him down to here. We're done. It's really pretty easy, and I just gotta get the positive and negative right, which I think I can do. I was just thinking about this a little more as I'm doing it, and I'm starting to wonder if this was a bit of a mistake. Assuming these capacitors are actually good, they have two insulated terminals on them, right? Both terminals are insulated. Like you can see that orange insulation there. So the can is not connected directly to the leads. The can is on the chassis. So the can is a shield of what's inside the capacitor. And I've replaced it with essentially unshielded capacitors. That's kind of what I'm wondering about now. This is the grid bias. Yikes, maybe this was a mistake. Maybe you need to have those you need to have these guys shielded. And it's right on the grid circuit, so well, we'll know. If what would happen? I guess you get a, I don't know what you would get. What would you get? Get a hum? What would you get from oh, it came right off. Yikes. This terminal is actually a grounded terminal. And now see. Okay. So the positive is actually grounded on this. Just a little backwards to what you normally find. Terminals here. Has that old TV smell. Just came out of it. Old TV smell. Now we might have a short right there. Let me just get this bit of unnecessary junk out of here. Wow, yeah, that's pretty close in there. But lots of close stuff. No shorts. Okay, so that takes care of all the electrolytic capacitors. Well, maybe not all of them. Maybe there's more in here. But those are all the main ones in the power supply. Both the B plus and the C minus. So I think we're ready now to operate the radio. So I think I'm just gonna stop the video for a minute and I'll say hi to my wife, and then I'll come back and fire this guy up. Okay, I think I'm ready to start it up. Now I've done a lot of work right on power supply, capacitors. So it's a little more riskier of there being something stupid in there from me, like a short circuit or something like that. So in the meantime, I've replaced the fuse in here. I blew the fuse in this the other day. I found out why I blew the fuse in there. It was a 3/4 amp fuse instead of a 4 amp fuse. I have the feeling I missed the 3 and the slash in 3/4 and just saw the 4. So it's gone. So now we got a new fuse in there, and the little light comes on. So this could allow me to raise the voltage slowly, but I still have the dim bulb system in here. So I'm going to bring this up, not all the way. So just double check something here. I've got everything good. Okay, so no power will reach the radio. We'll set this to, let's say, 80 volts or so. That's 80 there. That should be enough. Well, you know, it's a big radio. It draws a lot of current. This is a small wattage light bulb. Probably going to light this thing right up. when I first started up. But I can still check to see what the voltage is on it. The other thing is these capacitors that I've put in, they won't start working until the rectifier starts rectifying. So if I've hooked one up backwards, it really may not be apparent until it explodes. That's the truth of it. I just may not be able to detect the my error here fast enough. But I think I'm ready to go. Okay, so I got a couple of switches up here I need to throw. The radio itself, okay, it's switched on. I don't have any audio hooked up to it yet. We don't worry about that just now. I do have audio hooked up. Oh my gosh, I've had the volume turned up all this time. So you're gonna hum or something stupid on my video? No. Goody. Okay, I got my headphones on. And the volume out front is down. Okay, I think we're all set here. Now, what I'd be looking for in a radio is smoke, of course. Nice wisps of smoke. Oh, this is a heavy radio. Well, actually, I'm not looking for it. I'm hoping I don't see it. So, lots of light on the radio, so any smoke comes out of it, we're going to see it. Possible smoke locations, anywhere in here, anywhere in here, anywhere in there. So now I'm going to step right in front of the camera the way I have this set up. So I'm going to revert this a little bit different here, so I can. Plus, I need a clear path to the door in case I got to make a run for it. Okay. Next switch I throw will put power on the radio. It should cause this light to come on a little bit. Maybe on a fair bit, and we can monitor the voltage in this little guy here, like that. Good enough. It's my last chance to catch any mistakes I'm making. And we still have a ground connection on the radio via this clip over to my voltmeter. If I didn't have this clip on, the ground prong on the power cord here is plugged into nothing now. So the chassis is floating, except I've put this on it. So it's not floating. So I pull this off, something funny can happen with the radio. Okay, I'm ready. I think I'm ready. I guess there's a chance I could pop fuses in here too if I've done something wrong. Here we go. Oh, what was that? What is that? Oh, it's my phone. My phone in my pocket here. That's something, eh? just as I reach for the switch. Okay, no phone now. Watching the light, and we could watch this. This is now amperage, and watching this guy a little bit, and watching everything, watching everything. Okay, so light has come on, but not super bright. Voltage here is only 39 volts. You see the current draw is minimal. So everything is go. We are go for more voltage. So let's go a little higher here. The set has 58 volts. Even though it's starting out with like 110 here, a lot of it is dropping on that light bulb right now. In a state like this, it can take a long time for the heaters to heat up enough to get things going. You know what I didn't do is I didn't set up to measure the B+ that's developing. Let's do that. And that might give me some reassurance that I've done this correctly also. Okay, so we're on the 500 scale on this meter, and is there anything in the radio yet? Yeah, there is. Going down, so it's probably going down because the tubes are beginning to conduct a bit. Power draws up, the current draws up just a little bit of where it was. Still running the radio with only 60 volts. Is there really any concern here? So this is a positive terminal. I'm watching my meter go up. This is a positive terminal. This is a positive terminal. Okay, over here, the positive terminals are connected to the chassis, so we gotta flip my meter around. Should go upscale. Should go upscale. Should go upscale. Should go upscale. Not much happening there. Hey, what's happening there? This guy's doing nothing. Okay, then up higher in the radio here. This, it should go back. Oh, wait a minute, which is grounded? The positive is grounded, so the negative will have a voltage on it. So I'm all set to go here. I don't see anything. Okay. Now, you know what? It could be nothing because of the band I have switched on. Could be that this just isn't in the circuit. Same thing down here. It was this bottom one, wasn't it? No. Which one was it that showed nothing? Why do I think there was one that showed nothing? Yeah. Well, seems fine. I don't know. I don't know what happened to me there. Very good. Now, let's see what we can hear at this point. We're still just running with 61 volts on this radio. What can we hear? Okay, I gotta turn the audio up. Oh, so it should be, make this easier to hear. Should have this on AVC, which it is. Turn up the volume here. That's probably what's lacking. Hey, there's nobody coming out. No. Oh, what's wrong? Okay, what is wrong? Let's check. Well, it could be I'm still too low a voltage, but let's just check this here. Okay, so audio system's working. We're clipped in here. Hey, how come no sound? How come no sound? Don't like this. This is a bad situation. We have no sound. So I have a quick way of checking something here. I'm going to plug my own headphones into the radio itself here. Dead silence. What have I done? Total dead silence. I don't know. The last time I plugged headphones into this radio, I don't even know. Dead silence, eh? Let's take it up higher, higher voltage. So one way I can do that is screw that other light bulb in. That'll raise the radio voltage quite a bit. Still have the protection of light bulbs in the circuit, but now we're running with, it's not a lot more, 75 volts. How do you like that? Now we hear it. Does it sound like it's running where a tube is cutting off? Getting up, I don't know. just trying to analyze everything. Just trying to pick up hints off anything and everything. We'll go up in voltage now. Up in voltage by flipping this switch. And the hums come in. So we can hear the hum because of the way I have the volumes set. My sound system very sensitive and the output here very low. The hum is still there. The hum is probably not coming from here. It's probably the way I've connected the audio system up. Excellent. Voltages now. Voltages. So the radio is now running with 100 volts. I'm going to raise it up to 117 here. Okay, there's the correct voltage on it, 117 volts. Now we'll check the B plus values here. .300 volts. 260. 270. And over here, I think it's 51 volts, isn't it? Minus 51 that we should find. Depends on the setting of the RF gain. So that's over 50 volts, I think. Oops. It's way over 50. 75 volts. $85. $100. It's just dropping through these resistors here. Out here, the negative. That's the way it should be. It's actually a positive. 10 volts. Kind of didn't have to listen to all that noise during that affair. So I think this is a successful job done to this point. And now we get a chance to listen to the radio. That's my reward every time I do a little thing to it. I get a chance to check it out. Oh. Yeah, it's my audio connections here that are a little wonky. Let's put this down here. So right now we're on almost 10 megahertz. Okay, that's a little low frequency for this time of day. It's got 11 megahertz.
Abraham Lincoln firmó la Declaración de Emancipación y dijo, si mi nombre pasa a la historia, va a ser por este acto.
I'll leave it right there. The world is listening to the president. I'm going to go listen to him too. Okay, hey, just finished watching Biden's speech. Excellent speech. I hope everybody in the United States is listening carefully to what he's saying. Okay, so let's just play around here a little bit.
Presidenta de la Cámara Baja.
Okay.
So this, what we're listening to, it could be Cuba, but it could also be Radio Marti, which is the American propaganda system for telling the truth to Cubans. I'm going to guess it's Radio Marti because it's going a little far on the Americana here. I think that in fact was Cuba playing that because it appeared in two places here, and I know Cuba is in two places in this band. I just can't get it to show up on the camera here. I'm sure the world is paying close attention to what's happening in the United States, so it's not surprising on shortwave we keep picking up American stuff because of what's going on down there right now. Okay, let's shoot up a band here. This is 17 megahertz here.
CO2 levels pose a joint threat to ocean. 5-year-old from New York, United States, meditates for charity. New vegan fried chicken company launches in welfare group saves more bears from wild farm in Aulak, also known as Vietnam. All this and more on Supreme Master Television, your constructive global TV channel.
Supreme Master. Supreme Master Television is a worldwide television network. I'm not recommending it to anybody, just telling you what it is.
By the U.S. Agency for International Development, or USAID, is donating aid. No 6 weather storms are predicted for the next 24 hours.
Universal Time.
2 seconds. same as yesterday. Well, radar's working fine. The reception there, the kind of signals we're picking up, this is all just typical stuff. I'm not jumping up and down and going, wow, it's working great, and I'm not disappointed that it's somehow I've drained the life out of it. So far, so good. The real improvement in this radio is going to come from alignment. That's where the real improvement will come from. So thanks a lot for watching this video, and we're getting closer and closer to doing that alignment. actually what I got to work on. I'm going to show you. Can I show you? Probably can't see it. There's another set. Now this, it's on right now. I'm going to stick my finger in there. There's another set, a string of resistors in there I did years ago. That I'm going to fix that up. Anyway, thanks a lot for watching, and we'll see you on the next video.